And the Hosmer and Lemschau test has to do with homoscedasticity. I don't know if you guys wrote that. He said it during class.
Yeah.
So, but let's get back to you about the other question. Okay, what's next on the list?
Does he have contrast to discriminant analysis on that one?
No, but do you guys know the difference between logistic and discriminant analysis? Logistic regression and discriminant analysis? Okay, so we know logistic regression uses what types of outcomes? Dichotomous, okay. In discriminant analysis, this is when your predictors must be continuous. Outcomes, dichotomous outcomes, and discriminant uses continuous predictors. Okay, for logistic regression, you need more subjects, and it's less restrictive.
So some other things that are unique about logistic, it doesn't have to be linear. There's no homogeneity of variance assumption. It doesn't have to be homoscedastic. The DV doesn't have to be normally distributed. And it's a non-parametric test. It's also less restrictive than discriminant analysis.
All right, let's do.
It's less restrictive than discriminant analysis. Logistic is.
Logistic is less restrictive than discriminant. So was discriminant less restrictive than anything else? I might be confusing. Because I thought the discriminant analysis was the one that we were just discussing, that had predictors must be continuous, need more subjects, less restrictive than the economist outcome.
You may, no, you.
This is all in the heading of.
No, you switched some of those things. So, discriminant analysis, the predictors must be continuous. Okay. Logistic regression is less restrictive. And logistic regression needs more subjects.
Yeah. So for logistic, the predictor variables can be continuous, dichotomous, or categorical. For logistic regression, predictor variables can be continuous, dichotomous, or categorical. In discriminant analysis, predictors can only be continuous.
Good? Okay. Is that what you said out loud?
No, not
Okay.
at all. I was way off the grass.
Okay. All right, so let's do the odds ratio. Gevirtz talked about this on page 3 of the output of the logistic regression packet, if you want to follow along. So when you're looking at SPSS, is that?
Yes.
What does that say?
I think it was exponent.
Okay,
but-
so it's in the table called variables in the equation. Okay, and it's the one that's labeled EXP with the B in the parentheses. Okay, so that's where you look for odds ratio. It's in the table called variables in the equation. Okay, and it's the heading of EXP parentheses B, big B. Okay, so for this, you're only interpreting what's significant. And you can see the significance in the column right next to it.
Are we just specifically talking about the odds ratio?
Mm-hmm.
And I'm sorry, what just
You only interpret the odds ratio or the XB when it's significant, and the significance is listed right next to it.
so you want to significant?
Mm-hmm. Okay. If you take 1 minus the value that you're given in the column EXP with the B, okay, that gives you a percent. Okay, if your odds ratio value is less than 1, it indicates an inverse relation. Okay, so how does the review guide start? Probability versus odds ratio. Okay, so odds are the probability of belonging to one of the dichotomous outcomes. Probability of belonging to one of the dichotomous outcomes. My notes are really messy for that.
So the way to read it,
I didn't
Oh.
say that either, I forgot. So it's between 0 and infinity. We should go back up to this end. Let's skip some of this.
and it's the probability of belonging to one dichotomous outcome. So the way you read it is a 1 unit increase in predictor increases the probability of the outcome by whatever the value of the odds ratio is.
1 unit increase in the predictor increases.
The probability of an outcome by, and then whatever the value of the odds ratio is, when holding everything else constant.
What was the 1 minus the XP then? Isn't it, that's what, if it's significant, that's what our rate increases by.
That's the percentage.
It's the percentage.
So, it'd be like.
Because it's a ratio, so you can do, you can divide it. But in this case, they just subtract it from 1.
But like our number like 2.2.
So a 1 unit increase.
No, but the 1 minus.
Okay, I see what you're saying. Do you have that in your notes? The 1 minus?
No, I just have that it was 1 minus to get the percentage of,
Yeah.
I believe
The
it
way we
was
got it in class, it's just, 1 unit increase in your shared cookies increases the likelihood of finishing on time 2.21 to 1.
Okay.
The other page is more constant.
And I think that's the more important. So if you guys want to forget what I said about the 1 minus, that's fine. If that's more confusing, I don't think that'll be on there. But what Amber said with the,
Is it wrong or?
I don't know. I mean, I have it in my notes, but I'm not sure if it's wrong. Okay, yeah, I'm not sure about the negative, because when you subtract it, I don't know if you just get rid of the negative and multiply by 100, I don't know. So, I'm not sure, so I don't want to tell you the wrong thing, but I wouldn't worry about that.
It's the odds ratio, 1 minus the XP.
It's 1 minus EXPB.
Which is the odds ratio.
Okay.
Hmm?
It's nothing to do with the log, right?
I don't know if in this part. But don't worry about that. Know about the 1 unit increase. Okay, that's the most important part. Okay? Everybody good with that?
And then, I think I have,
They had to do all of the B weight. We have to do probability.
and then probability is the last one, which is the likelihood of event occurring. And it ranges from 0 to 1.
But we have to be able to convert the negatives, though, right?
Yes.
You were talking about.
Okay. So you guys go with probability in the table, the percentages and stuff? Okay, what's next?
Can you explain binary
Binary, yeah. Because, again, it's classifications of zeros and ones. It's how you code the data.
Yeah, that's done.
Right. That's, yeah.
Yeah, so you just give numbers. Excuse me. Okay, what's next? He doesn't have the adjusted odds ratio.
You dummy code things based on if somebody falls into a category. So 1 indicates yes, they fell into a category, 2 indicates no. Or 0 indicates no, not 2, sorry.
So you guys remember in the output he went over, he said that B weights are like logs? Okay, so I think that's what that means when he listed B weights. And standard errors, that's like the Monte Carlo study.
Does he have influence statistics on his output? I guess from another exam.
Okay, the 2 log likelihood, that's on there, right? That's, or the negative 2 log likelihood? Do we do that one? Okay. What are we missing? Standard error. That's like the Monte Carlo. Okay, that's the standard error of the B weight. When it's talking about standard error in that table, it's the standard error of the B weight. Okay. What else are we missing, guys?
If it's inflated, or just with the standard error, if it's inflated, that's what affects the walled statistic.
Because you're the B weight over the standard error, you get the result.
Yeah, so it causes distortions. So that's why the walled statistic can get inaccurate, is due to the standard error. So, yeah, it's a really good question. I'd ask Gevirtz.
So it's not like it's really good.
Right, like it's, yeah, and it's not like there's a cutoff where if it's like above a certain number, it's inflated. It's, you know, it's going to vary from test to test.
So for some reason in our notes, we both have influence statistics. Okay, and those were from the first exam, but they're not on your study guide, but I may just glance over them real quick. So those are the cooks, the leverage, DF beta, Mahalanobis. Okay, so just remind yourself of those. I know. Cooks, leverage, DF beta, Mahalanobis.
Knowing what each one does and all of those.
Yeah.
What about the Cohen's kappa that you said earlier?
So it looks at inter-rater reliability. And it's an agreement statistic that corrects for chance agreement. And the way that you do that is you take the hit rate over the non-hit rate for chance agreement.
Is that for the influence statistic?
This is for Cohen's kappa. This is how you determine inter-rater reliability.
You said it looks at inter-rater reliability and
That's it. It just looks at inter-rater reliability.
That's all.
So it's not an influence statistic.
Correct.
Before we move on to something else, when they were talking about before converting a negative B
Mhm.
log, if you have one that is one of the predictors that's significant but it's negative,
Mm-hmm.
is that when you do the anti-log?
Mm-hmm.
And then what do you use that number for again? It's the off ratio.
And then that's where you can say about the increase, or the but then would you say decrease? Yeah.
And I think he went over that one in your handout that he gave you. I thought I saw anti-log in here. Yeah, so on page 3 of the logistic regression output, slide 4, he talks about the antilog.
What about the equation?
You know the negative ways?
Mm-hmm. Yeah.
Is this the equation?
Yeah.